Alright, in this video we're going to talk about Newton's first law, which states that an object in motion remains in motion, an object at rest remains at rest, unless it's acted upon by a net force. And we're going to work a lot of problems in this video, and I'm going to start with this table shown here on this page. I think it's very important to understand whether the forces are balanced or unbalanced in all of these scenarios, whether an object is at rest, moving at constant velocity, or accelerating, and whether a net force is present. Okay, so let's start with when an object is at rest, the forces that are acting on that object have to be balanced for it to be at rest. So balanced goes here. And if the forces are balanced, there is no net force, so the net force is zero. For an object moving at constant velocity, say like 65 miles per hour, if you're moving at a constant velocity, the forces acting on that object are also balanced. And if the forces are balanced, the net force acting on it is also zero. Okay, and then finally for an object that's accelerating, so it's going from 0 to 60 and it's accelerating in a certain amount of time, the forces acting on that object are unbalanced. And so the net force would be anything greater than 0. So greater than 0, any number greater than 0. All right, let's try a few physics problems dealing with Newton's first law. Okay, in this first problem, it says to use the free body diagram shown below to answer the following questions. In the first question, it says, are the forces acting on this object balanced or unbalanced? And before we talk about it, maybe it's important to review in physics the sign notation. So if you've got an object moving up, the sign is positive. If it's moving to the right, it is also positive. But objects that move to the left and objects that move down have a negative sign. And so when we look at this if we're trying to find out if the if their forces acting on this are balanced or unbalanced, we have 10 newtons of force going up and 10 newtons of force going down. And so if you were to add these together, you will see 10 newtons going up, and you're going to add that to the 10 newtons that are going down. But because it's going down, it's got a negative sign, so we're going to add a negative number, and it's 10 newtons as well. And so you'll see that they add together and they add to 0. And so there's balanced forces here. These are counterbalancing each other. If you look in the left and right direction, that is also the case. 30 to the left, which would be negative, and 30 to the right, which is positive, so they add up also to 0. And so in this situation, the forces are balanced. Okay, on part B it says, is there a net force? If the forces are balanced, the net force is equal to 0. And you'll see it written like this, force net is equal to 0. And part C, if the object was originally at rest, describe the change in motion of this object. If this object was already at rest and now all the forces acting on it are balanced and they add up to 0, then it's going to remain at rest. So how is it going to change? It's not going to change. It's going to remain at rest. If you think back about Newton's first law, an object at rest stays at rest, an object in motion stays in motion, unless it's acted upon by a net force. And in this case, there is no net force, so the object is going to remain at rest. Okay, let's look at another one. Number 2, it's the same type of questions as we answered in that first problem. It wants to know in part A, are the forces acting on this balanced or unbalanced? We have 10 up, 10 down, so in the up and down direction, the forces are balanced. And also in the left and right, we have 30 to the right, 30 to the left, and so they add up to 0 as well. So these forces are balanced. The net force is going to be equal to 0. And if this object was originally moving to the right with constant velocity, describe the change of motion of this object. So this object was going to the right at a constant velocity, and now it has all the forces that are acting on it are balanced, so there's going to be no change in the motion. It's going to continue to move to the right at constant velocity. So continues to move right at constant velocity. So it remains moving right at constant velocity. And that will be your answer for that part. Okay, let's try another one. Number 3. Again, it's the same type of question. A says, are the forces acting on this object balanced or unbalanced? If you look up and down direction, we got 10 up, 10 down, so those are balanced. But if you look in left and right, now we have 60 to the right, which is positive, so 60, and 30 to the left, so that's like adding a minus 30. And so you're going to see a total, if you added them together, of 30 newtons. Okay, so the forces acting on them are unbalanced. There is a net force in this situation, so force net is equal to 30 newtons. And it's positive 30 newtons, so that tells you that it's going in the right direction. And in part C it says, if the object was originally moving to the right with constant velocity, describe the change in motion of this object. Well, now we've got a net force acting on it. And according to Newton's first law, the object's motion is going to change. Instead of moving to the right at constant velocity, now it's going to accelerate to the right. Accelerate to the right. It's going to accelerate in the direction of that net force. Okay, number 4. In this problem, we're trying to determine whether the forces are balanced or unbalanced. Let's look up and down direction first. They're balanced, 10 and 10. Left and right, though, we see that there's 80, and that's in the left direction, so minus 80 plus the 60, that's going in the rightward direction. And so if you add them together, you're going to get a minus 20 newtons. And so the forces in this situation are unbalanced. There is a net force, and the force net is equal to, well, say 20 newtons to the left. You have to be careful. You can't write minus 20 newtons, because it could also, minus 20 newtons could mean that the object is experiencing a net force down. But if we say 20 newtons to the left, there's no confusion. In part C, it says, if the object was originally moving to the right with constant velocity, describe the change in motion of this object. So the object was moving right at a constant speed, constant velocity, and now it's experiencing a net force to the left. And so what that's going to cause the object to do, it's going to decelerate toward the left. So for example, if it was going 65 miles per hour to the right, and now you experience a 20 Newton force to the left, it's going to slow down, accelerate until it gets to 0, which is also called decelerate. And then if it continues, it will actually start accelerating to the left. And so that's how the motion of that object would change. Okay, and number 5, it says, same type of question, are the forces balanced or unbalanced? If we look up and down direction, they are balanced, but left and right, they are also balanced as well. And so these forces are balanced. The net force, if they're balanced, is equal to 0. And it says here in part C, if the object was originally accelerating downward, describe the change of motion of this object. So it was accelerating downward, but now it's experiencing no net force. And so this object will continue to move down, but it will move down at a constant velocity. So it's going to move down at constant velocity. An example of this in a real-world situation might be a skydiver. At first few seconds that he jumps out of the plane, he's going to accelerate downward. He's experiencing a net force. But there comes a moment in time in which the forces in the upward direction on that skydiver will equal the force of gravity pointing down. And that upward force is the force of air resistance. And once that happens, the skydiver will continue to fall, but he's going to move down at a constant velocity, in which case we call that terminal velocity. Okay. One more question. In this situation, are the forces balanced or unbalanced? If we look in the up and down direction, they are balanced, but in the left and right direction, we have 200 newtons to the left, so that's like saying minus 200 newtons plus 180 in the rightward direction, and so that's a minus 20 overall. And so the forces are unbalanced in this situation. The net force is equal to 20 newtons to the left, and let's read part C. It says, if the object was originally accelerating toward the left, describe the change in motion of this object. So it was already accelerating to the left, and now it's experiencing 20 newtons of force toward the left, so it's going to keep accelerating. So there's going to be no change in this object's motion. It will remain accelerating to the left. So it's going to accelerate to the left. Okay, hopefully that helps you in understanding some of these Newton's first law questions. Really have to look at whether the forces are balanced or unbalanced, and see how that will change the object's motion. What I have for you now for this video physics assignment are 7 questions that are going to follow on the next few slides. And what you'll do is write them down on a piece of paper and write the answers down on a piece of paper, and you're going to turn those in for points. So what I'm going to do now is slowly scroll through the 7 questions. Remember, you can always pause your video until you answer that question, then you can move on. But hopefully that helps you. If you do get stuck on one of them, remember, I'm always here to help. Stop by at any time, and good luck.